Okay, in this video, let's talk about binary search. Um, so binary search is just a search with a fancy name binary, and we'll see why that name comes in a while. But let's focus on the fact that we are trying to search for something. So what are we trying to search for, and where are we trying to search for? These are two important questions to ask before we even start searching. So what we are trying to search for is where a number is. So we're trying to search for where a number is, and where we are trying to search for is basically in a list of numbers in ascending order. So let me repeat that. We are trying to search for where a number is in a list of numbers which is in ascending order. So this is that list of numbers in ascending order, and we want to find where a specific number is in that list. So for instance, if this is the first number in the list, this is the second number in the list, and so on, and this is, let's say, the 10th number in the list, and if this is the number that we're looking for, then the the answer that we need from binary search is 10, because we want to know where the number is that we are looking for, and this list has to be in ascending order for binary search to work. Okay, now let's understand how exactly binary search operates. What it does is it basically approaches this problem in the most efficient way. Now let's look at a few ways in which this problem can be approached. If you want to search for a number in this list of numbers, you would probably start from, let's say, the first number and say if this is the number that you're looking for, no. Is this a number that you're looking for? No. And so on until you come across the number that you're looking for. But what if the number that you're looking for is towards the very end? You'll have to unnecessarily compute all with all these numbers until you reach your desired number. So that's very inefficient. Instead, what if you start from backwards? Again, the same problem. What if the number that you're looking for is right at the front? Then you would lose a lot of compute in just doing your propagation. Instead, what if we divide this entire list into two smaller lists, two halves actually, and then try to figure out which half the number belongs to, and only then search for our number in that half. So that's exactly what binary search does. It basically divides this list of numbers into two halves, and then it asks just one question: whether this is the number that it is looking for. What that means is it asks whether the first number in the second half is the number that it's looking for. If it is the number that it's looking for, then awesome, that it just found the number. But if it is not the number that it's looking for, then it asks another question: is the number that it's looking for greater than this number right here? If it is, then the number definitely belongs to this half. But if the number that it's looking for is less than this number, then the number definitely belongs to this half. There's a small edge case here where if the number that it's looking for is greater than this number, then it doesn't have to consider this number in this half, but for simplicity I have considered it as a part of this half. In the code later in the next video, we are going to see how we handle that case. But for now, for a conceptual understanding, you can assume that we are dividing the entire list into two halves. Okay, so once the binary search decides whether the number that it's looking for is in one of these halves, it takes that half and then does the same operations that it has done so far, which basically is dividing that half into two halves again, and it keeps on doing that until it keeps halving all of these halves and then reaches to the one element that it finally is looking for, and it gets that element and the position of that element. Now, to keep a track of where exactly it is in this entire list, because it's breaking into half and then another half and then another half, and then it'll keep shifting its focus from the original list to these halves. So we need to keep a track of where in the list we are. So initially, since we are at the very original list, we call the original beginning and the original ending of the list as the beginning and the ending elements. As we go to each of these halves, our beginning element can be shifted to this if this is our half, and the ending element could be shifted to this if this is our half. So depending on where we are, within our algorithm process in the iteration, we are going to decide where the beginning and the ending elements are. So you'll see it in the code in a much clearer way, but for now you get an understanding of how the binary search operates with the original array, breaking it into halves, shifting the beginning to whichever half it is looking for. So if this is the half, then the beginning shifts here. If this is the half, then the ending shifts here. The beginning stays here. Similarly, if this is the half, the ending stays here. And so on until it finally boils down to that one element where the beginning equals the ending, and that is the element that it's finally searched, and the position will be just the value of the beginning or the ending index. I hope you understood this. If you did not, you can go back to the video and kind of listen to it again. I hope you enjoyed the video. Thank you.